Hi and welcome. My name is Isam. I'm the senior designer at ISD Architects, where we help people, homeowners and building owners, realize their dream homes and dream businesses through designs that are creative, efficient, and sustainable. In this video, we're going to pick up where we left off the last video, in which we talked about the schematic design, but we touched upon and we focused on the conceptual design as a major component of the schematic design. There are four elements that we take into consideration when we do schematic design. It's the site, or the nature of the site. It is the space planning, which comes, as we said, from the functional program. It is the site, the client's self-image, what they want to see, what their image in society, in the context, whether it's a personal image such as a personal home, or a business image like a corporation, a hospital, an office building, a condominium. What is the client's image of his or her building? And then finally the architects. Those are the elements of a schematic design. At this stage, we must deal with all these factors in order to come up with a concept, then come up with a schematic design that discusses and elaborates that concept. Another idea I would like to explain in the schematic design is the idea of design approach in the schematic stage. So there are two basic approaches for the design. This is a more conventional approach, and this is what we call the integrated design approach. I would like to explain a very quick difference between the two. This is almost an obsolete. It's still practiced. However, there is a lot of concern about this methodology, the conventional, where the architect becomes it's kind of a pyramid structure, where there is a head that makes the decision, and those decisions trickle down to the other strata of the pyramid, meaning the consultants and the tradesmen and the contractor and so on and so forth. So all the design decisions in the conventional schematic design are made by the architects. It could also apply to areas of small addition, small renovation, but the modern buildings, the more sustainable buildings, the green buildings, green homes, use the integrated design approach. Now, as you can see, it's a cyclical, it's an interactive. You make a decision as a group. And what is the group? The group is, in addition to the architect, there is the consultants, there is the structural engineer, mechanical engineer, acoustic engineer, electrical engineer, geotechnical engineer, the site engineer, and so on and so forth. And sometimes more consultants like lighting engineers are required as well. In addition, so we start in the interactive design approach, integrated design approach, by combining all these players, and the architect would be one of the players, and not so as you can see, this is more integrated, is more interactive, this is more mechanical. It starts from a point and trickles down to the rest of the people or the team members. Here it is more a shared approach. So we get to know and discuss and assign the goals with the owner as a major element, as a major player in this endeavor. So at this stage, we start with talking to all the parties involved, and also the contractor, if possible, It's a different. It is a different contractual methodology. However, it is encouraged that the contractor be on board, but it's not a must. At least the design team should be on board, and then the design proceeds. The design proceeds, and then comes back to be checked and verified, and then proceeds again. So as you see, the approach is more integrated than this one. All the design decisions are made at this stage and then handed out to the other members. Here, the design decision is based on collecting information from everybody, and then a decision is made. So it's not only tactical here. We're not only about tactics. It's the strategy. The approach is different. So we prefer that. However, many different factors would prevent sometimes the architect or the owner from going in that stage. For example, when we do a passive house or a green home, we definitely need this approach. We cannot rely on this approach. Why? Because the tradesmen, the contractor must all be well trained to tackle with a green home. We cannot just design everything and then wait for any contractor or any tradesman to deliver the quality and the performance of a passive house or of a green building. So you see that how the approach of the schematic design starts at this stage, or the approach of design in general starts at the schematic design stage. Now I would like to move on to what we call the space requirements layout. This is a major component of the schematic design stage that comes after we find the concept, we know our direction, we know where the inspiration is coming from, and we define our alternatives, and now we move into the space requirement layout. So the space requirements layout has two components that I would like to capture here. The first one is what we call the bubble diagram. But the bubble diagram, as we explained earlier in the last video, it talks about the importance of the spaces, the square footage, the areas, and the relationships of the spaces. And of course there is orientation, and there is the sun path, and so on and so forth. And there's other factors like vegetation or views and so on and so forth. However, that is more about the space requirements, and in order to finalize this with the owner and make it clear how we envision that the space requirements would be tackled, would be performed. And the other aspect is what we call the building efficiency. Now, building efficiency is normally dealt with by the architect, and it's very important. The building efficiency means the net area over the gross floor area. So the net floor area over the gross floor area. For example, we have an apartment building like this, where we have different apartments on a certain floor. Now the net area is the area of the apartments themselves, just the apartments, just the usable space. The gross is the total building area, including the utilities. For example, elevators, fire escapes, like these stairs at the end of the corridors, elevators, janitor room, mechanical room. All of these, what we call, we add to the apartments, and then we get the gross floor area. The percentage of that is a major element in defining how well do architects perform their job. If that percentage is high, that means it's a better building. For example, if you say that the efficiency of the building, or the space efficiency of the building, is 90%, and the same building with the same floor area or the same number of rooms or number of apartments has an efficiency of 75%, then obviously you would go to the 90%, provided that everything within the public spaces or the service spaces is according to the code. That you're not bringing your corridors or hallways so narrow that it would be rejected by the by the building code at large. So maintaining the minimum of the public spaces and the service spaces while maintaining the maximum use of the apartment, or the leasable, as they call it in retail architecture, the leasable space, then you get a higher percentage of efficiency. Now, I try to capture another concept here. When you increase the efficiency of the building, you reduce the gross floor area. I don't have time now to explain that, but this is a fact. When you increase the efficiency, this over that, then the gross would be reduced by X factor. So you get the same net floor area, but because the efficiency is higher, then you get the same net area but more efficient building. That is the role of the architect in this game. Now, as a conclusion, I would like to discuss what we've reviewed in the last two videos, especially in this video. So we conclude that the schematic design is the stage where we take care of two elements: the inspirational element, or the concept that comes from the mind, comes from brainstorming with the owner and the many explorations that the architect or the designer does, and also from the physical requirements, including the layout, the site, the system used, structural or otherwise, and other elements that are really physical, that expresses the need of that facility, the need of that building. I couldn't but to balance and interactively work with these two in order to get a creative design, but also efficient design. And we talked about the efficiency of the building, which is the net over the gross area, but we also need to be inspired. You need to design outside of the box. We need to be progressive in our thinking, especially when it comes to energy. A lot of myths revolve around energy efficient building, or green buildings, that they are so limited, they are so physical. That is very far from truth. It really depends on your designer. It depends on how creative you want to be. The concept is the same. There is the spiritual part, there is the inspiration part, and there is the physical part. You have, or we as architects, we must balance out these two requirements at this stage. Otherwise, the whole process would not be fruitful if you proceed to the design development stage, or the technical drawing stage, or the permit, or the working drawings. And then the following stages, of course, which is the contract administration. You would inherit any imbalance, I would say. Any imbalance that happens here would be inherited in those. And it's not only about, it's a lost opportunity. Other than losing money or being uncreative, which is eventually, it's a failure in positioning you in a society. It's in positioning your company or your home as not only an efficient home from that perspective, but also a creative home, a pleasant home, a progressive home that opens up the horizons for innovation. And this is what we aspire to do at ISD Architects. I hope you find this video useful. Please visit our website at www.isdarchitects.com and look around and see if we can provide any help for you. Until the next video, in which we're going to talk about the design development stage, I wish you all the best and take care.